They say it takes power to lift thousands of tons of steel, but they are wrong. What keeps the world from collapsing is not muscle. It's a tolerance smaller than 1 millimeter. Where the wind roars louder than voices, a motion delayed by 1,000th of a second can tilt a billion-dollar structure. Steel cables tremble. Droplets of hydraulic oil reflect the sun like a heartbeat of the machine. Politicians will never tell you this. These giants move by laws so precise that a 0.8 millimeter deviation could end it all. Here, gravity is not an obstacle, it's the judge. Precision is not a choice, it's survival. Remember, every perfect lift begins with respect for gravity. Before a single ton leaves the ground, every millimeter has already been modeled. Tens of thousands of stress points, centers of gravity, and crosswinds are simulated through 3D mapping and supercomputers. Data is refined to the thousandth of a radian, each newton tracked like the heartbeat of a living structure. In these quiet control rooms, engineers don't talk about beauty, they talk about stability. Every joint, every bolt, must endure 300 times its own load. A wrong line of code, a misplaced digit, and the city shakes. They don't work for glory. They work for something greater, the responsibility of defining safety itself. These calculations don't just hold steel. They hold the honor of the craft. Don't look away. What comes next is how humanity turns mathematics into power. They call them titans of steel machines that breathe, lift, and balance the impossible. Crawler cranes, gantry systems, hydraulic towers, each moving under 700 bars of pressure. Every piston stroke is a negotiation between oil, steel, and gravity. The central pump drives coolant and pressure through veins of thick steel pipes, cooled by liquid nitrogen to maintain equilibrium. A single misaligned rotation, even 0.3 degrees, can twist and destroy everything. Each metallic click from a pressure valve means the world is still balanced. Steel groans, wind howls, but the cranes move like Swiss watches, silent, exact, relentless. Yet power is only the surface. What keeps it from breaking lies in perfect synchronization, the thousands of electronic minds you're about to witness. Inside the control room, over 400 laser sensors track every fraction of movement. Data returns in real time, within 0.002 of a second. LED panels map stress, wind, and torque across every beam. Engineers don't shout. They watch the light shift, listen to the numbers breathe. When one cable drifts by 1.5 millimeters, the system responds, the left releases, the right tightens, perfectly timed. It's an orchestra, without sound humanity conducting physics. And when everything aligns, time itself seems to pause. No voices, only order. When silence becomes the only language on site, the true lift begins. No system is safe from nature. A sudden gust can rewrite every equation. At 5,000 tons, a 10-degree change in temperature makes cables stretch 6 millimeters enough to shift the entire load. The ground trembles. The air hums. Workers stand still, not out of fear, but out of respect. Pressure sensors beep like distant metronomes, reminders that survival is measured, not granted. In this world, patience is power. Movement that's slow is the only kind that endures. Stay focused. The perfect lift is seconds away, held by nothing but a millimeter of steel. A blue laser slices through the humid air, tracing the path of balance. The number on screen reads 0.8 millimeters. The load freezes midair. Cables vibrate softly. Wind slips through the frame. At that moment, humans and machines breathe as one synchronized signals, heartbeat, reflex, all moving under the same invisible law. A perfect lift makes no sound. Only silence, dense, heavy, flawless. But behind perfection lies a razor-thin margin between order and disaster, one you're about to see unfold in milliseconds. In heavy lifting, 2 millimeters can destroy everything. The disasters are archived like the 2017 collapse in South Korea, where a 2,000-ton bridge beam failed because a sensor drifted by 1.6 millimeters. The frame bent. The world went silent. Engineers learned, recalculated, and wrote new laws of safety. Every lift since then is a survival test, not a routine. Precision isn't perfection. It's the fragile distance between endurance and ruin. Inside every error lies a memory, and that memory becomes the next standard. Once you understand the edge of error, you understand why precision is the only language gravity respects. As the sun falls behind the steel horizon, the cranes stand still, monuments of discipline and design. The operators step down from their cabins, walking through the fading light. No one knows their names, yet every millimeter they lift carries decades of learning and faith. In this world, there is no perfection, only accuracy. repeated long enough to become ritual. The next time you see a bridge, a turbine, or a ship rise into the sky, remember, it stands not by strength, but by those who believe in less than 1 millimeter of error. Humanity doesn't conquer gravity. It earns permission to exist within it. Respect the precision. Respect the process.